Welcome our SVM 11th students. We are going to see about second lesson. In second lesson, up to that 2.6 over. Now we are going to see that 2.7. This 2.7 topic is distance and displacement for object moves from one place to another place. So we are saying an object moves from one place to another place. If object moves, its position is changes. If the object does not move, position does not changes. If a position with respect to time remains same, means object is at rest itself. So we have a rest condition. If any particle or any object or human being or bus, if it is a rest, means with respect to time its position remains same, then that particle is at rest. Here position of the object does not changes. Changes with respect to time. And then object is at rest. So that rest object will not make movement from one place to another places. Only the object moves from one place to another place, means their position is changes. If position changes with respect to time, then we are saying the object is in motion. There we can say the object moves with respect to time. So its position that is object's position changes with respect to time. Time to time, respect to time, the position changes with respect to time, means then the particle or any object in motion, then only object makes distance traveled, or there we have a displacement quantity also. Distance as well as the displacement we are going to see. So first we will see about that distance traveled. There we can take one example. One man traveling from one place to that another place. Example, their place name may be A. Another place name may be B. There, the man moving from A to B Many paths we have. Direct path we have. Other paths we have. If we required, directly he want to move from place A to B. That may be taken as a path, first path may called as a path 1. Its length may be, example, 1 kilometer. Suppose man want to travel in another path for purchasing some materials on the way. There, another path we have. This path may be taken as a path 2. Here one shopping is there. That man want to purchase some materials. So that's why he is moving in that second path. But it may be a larger distance, but he required. So, example, this path length may be 1.5 kilometer. He want to move from A to B position. There, first path, without purchasing, directly moving from A to B. So, no problem. There, shortest distance, 1 kilometer. But sometimes he want to purchase books or some materials. For that purpose, he want to move in that second path. There, that length is 1.5 kilometer. Then we have another path. It may be a different shape, not a uniform shape, zigzag shape. The path 3. That length may be, take an example, 2 kilometers. So he need to travel this path. There, he want to purchase some materials. Okay. There we have third path. Through this third path, he want to travel because there one shopping is there. That purpose, he want to purchase some materials. That purpose he is traveling. There, path length we have. Path 3. Their length is 1.25 kilometer. 1.25 kilometer. So, he may travel from A place to the B place, maybe in a 3 paths. First path may be a shortest path we can take on, that is 1 kilometer. Second path may be a somewhat larger distance, that is 1.5 kilometers. Third path we have. Suppose he traveling in this path only, length of the path is 1 kilometer alone. At the time of traveling, the distance traveled want to calculate. Actually, distance traveled is nothing but actual length of the path at the time of motion. Actual length of the path at the time of motion. So, in path 1, length of the path, path 1 length, value is 1 kilometer. We can say at the time of moving from A to B in the path 1, he distance travelled value equal to 1 kilometer alone. But if he travelling through the path 2, in path 2, actually its length is, physical length, 1.5 kilometer. That distance travelled equal to 1.5 kilometer. Another way, third way we have, that is in path 3, the total length of the path 1.25 kilometer. If he moves in the path 3, distance traveled is 1.5, say 2 pi kilometer. So, distance traveled between the two points maybe varies, because the path varies means length of the path is varying, then the distance traveled also varies. So that's why in general we have a distance traveled definition. Distance. If a man moving in particular path, that can be taken as the actual length. Distance is actual length of the path through that object moves. Object makes a motion. Motion with respect to time. Anyhow, time is a independent factor. Time changes. Time we will not control, but with respect to time, we can change our position. So that's why distance is nothing but a actual length of the path through that objects may be taken as a particle, makes a motion with respect to time. These distance units, there we have a SI unit measuring the distance in meter. SI unit is a meter. Then another unit we have CGS unit, nothing but a centimeter. Centimeter is a symbol, can be taken as a small m, small cm. Anyhow, that distance is measured in meter in SI unit, centimeter in CGS unit, and it is a physical quantity which has a magnitude only. If any physical quantity which has a magnitude only means that the physical quantity is a scalar quantity. Scalar quantity contains only a magnitude, no direction. If any physical quantity means that is a scalar quantity means it has a value. Time to time, position may be changes. If a position changes, it has a certain value, but it is only the positive value. Not in negative as well as the zero. But it takes place many values if object moves from one place to another place. Not only one value, it takes place in many values. So, distance is the actual length of the path through the object makes a motion with respect to time, as well as its unit in SI is meter, in CGS centimeter. It is one of the scalar physical quantity. If any physical quantity is a scalar means it has only positive value. It can be take place not only one single value, definite value, it may be contains more number of values, because we given that example, if we move path 1, path 2, path 3, the distance traveled value is changes. So that's why it takes place more than one value. There we can give an example diagram also. In a one-dimensional motion, x-axis if you taken is may be taken as an origin, is a positive x-axis, is a negative x-axis. Man is moving first from the origin towards the positive x-axis in a t1 time. He can cover x1 distance. After that t2 time, x2 distance. If time taken is a t1, their distance travelled is x1. Suppose the time taken is a t2, their distance travelled is x2. He may return back through the same path and maybe reaches the final position here. If it is a 1 meter x1, then it is another 2 meter. This alone 1 meter. From x1 to that x2, another 2 meter. Further he is moving from x2 position to that another third position. This may be taken as a 3 kilometer. So he distance covered, that man distance covered from origin to that x2, then he moves from that x2 to that C position. Okay. First position is initial position, origin. First he covered 1 kilometer in a t1 time. That final position is that is a x1 position. Then he travelled t2 in a t2 time 2 kilometer. After that he moves from that x2 position to the C position. Will be taken the time t3. But anyhow, here we are going to take distance travelled alone. No need that time. That's why x1 plus x2, this distance, plus further from x2 to the C can be taken that value as a x3. So we will substitute that values 1 kilometer plus 2 kilometer plus here that distance is 3 kilometer. But even though he is moving from x2 position to that C, already 3 kilometers plus 3 kilometers, 6 kilometers. Then we can take total distance travelled is 9 kilometers. 9 kilometers he travels. Suppose another time he is travelling from origin to that C directly. Only he travelled 3 kilometers alone. So that's why it takes place many value. He may be moves in any path. His required path may be his wishes. So that's why if he moves from origin to that x2, then x2 to C means total distance is travelled is 9 kilometers. But directly he want to move from the origin to that C without moving that opposite direction, and only that 3 kilometers. That's why we are saying it takes place more than one value. That is the example diagram we can take. And if it starts to move means it contains some value, non-zero value. It is a non-zero value. Distance travelled is a non-zero value. Any he started to move means automatically just some distance. Some distance means we have certain length, some length we have. That's why non-zero value it takes place. That is the distance travelled by that man or any particle from one position to that another position. Only it is a scalar quantity. Once again listen. Now we are going to see a rest. When we are saying the particle is a rest or object is rest means position of that object does not changes with respect to time. Then that object is a rest only. When we can say the object is in motion means position want to changes with respect to time. At the time of position changes, there we covers some distance. The distance may be actual length of the path. The path may be any region we can take, any direction we can take. No need of direction here contains. So that's why the path may be actual length of the path may be a different. So total actual length of the path, that is distance is nothing but actual length of the path through the object makes a motion with respect to time. Then that is called as a distance travelled. And there are units and it takes place some different values only. Another one we are going to see that displacement. This displacement takes place only one value. How we are taken the diagram. That we have a definition for the displacement. Example diagram. We have position A. It is position B. Man want to move from the position A to B directly. It is the shortest distance. Path may be many shape of the path. Here he is moving from position A to B directly with a direction. With a direction. It is the shortest path. That the length of that shortest path may be taken as a displacement. So we have a definition for that displacement. It is the shortest distance between initial to the final position. Suppose it is a 1 kilometer length maybe takes from north to south. Is taken as a north to south. North to south means we are saying direction also. That's why this displacement quantity may be defined as shortest distance between initial to the final position with respect to time. Any that is a distance or displacement take place means with respect to time we can see. Then only there we have a motion. Anyhow, any man moves from position A to B through the shortest path from north to south, there that may be taken as a displacement. So it contains magnitude with direction. Magnitude with direction means it is a vector quantity. This physical quantity is vector quantity. Any physical quantity which are vector means both magnitude with direction. So, we are taken in three types now. Motion may be taken in three types. One-dimensional motion, two-dimensional motion, as well as the three-dimensional motion. If any man or particle moves in a one-dimensional motion means either exact direction, Cartesian coordinate system in there may be taken in x direction, that is the positive x, positive y, negative x. There it is a origin as well as 1, 2, 3, 4. If a man is moving along this or in this path only along the x-axis, x component alone varies. Other two components means if it is a three-dimensional, other y-axis values remains constant and z-axis values remains constant means particle can be moved in a one-dimensional manner. X value only changes. If it is the initial position and it is a final position, total length may be taken as 4. It may be in that unit of kilometer means 4 kilometer only. Further he is moving from that origin, it is a A position. Further he is moving from A to B. Here we have in a kilometers -1, -2 and here -3. Further he is moving from A to B. Now what is the displacement? First of all, man is moving in the positive x direction. Further he is moving opposite direction. So here we are representing -3 kilometers. This minus shows negative direction. Here its value is only positive because of positive directions only. Anyhow, depends upon that initial and final position only. We are saying the displacement value, but in that actual direction to that opposite direction means we are saying in a negative. So if it is a one-dimensional motion, x value only varies. If it is a two-dimensional motion, at the time particle initially at this position, there we have a certain, that the position P1 has a certain distance, that is from the origin R1. This can be represented in the R1 vector. The particle moves from this P1 position to that P2 position, their value R2 vector, but it is moving, particle is moving from position 1 to position 2. This shortest distance taken as a displacement that may be represented as a del R vector from P1 to P2 is moving. Then how we can take an del R vector equal to R2 vector minus R1 vector. Suppose if it is a two-dimensional motion, R1 vector can be taken as x1 into I cap, that is a I cap x direction, plus y1 into j cap. Similarly for that R2 also, R2 vector equal to x2 into I cap plus y2 into j cap. If we substitute here del R, that is the displacement of the particle from a position P1 to P2 in a two-dimensional manner, del R vector equal to R2 vector. First we want to substitute R2, so R2 contains x2 into I cap plus y2 into j cap minus of x1 into I cap plus y1 into j cap. If you included minus del R vector equal to x2 minus x1 into I cap plus y2 minus y1 into j cap is a displacement vector. Displacement vector, it contains both x component and y component. Then the del R vector can be taken as del x into I cap plus del y into j cap. Del x is equal to x2 minus x1. Del y equal to y2 minus y1. And I have magnitude of x component can be taken as a modulus in the modulus form. It contains both direction and magnitude. Magnitude only means take modulus on both sides. Can be square root of del x square plus del y square. Otherwise we can use the equation x2 minus x1 whole square plus y2 minus y1 whole square. Magnitude alone, but it contains both magnitude and direction, as well as only the direction want to represent means from initial position to the final position. That is the direction of that displacement, not from the final position to that initial position. The direction of the displacement is taken initial position to that final position, but at the time of calculating the value, we must take x2 minus x1 whole squared plus y2 minus y1 whole squared. Like that we want to take for finding that magnitude. It is a two-dimensional manner. Another, if a particle makes a three-dimensional motion, means there we have a three-axis component that we will see the diagram, Cartesian coordinate system. Displacement vector in the Cartesian coordinate system. There, three-dimensional manner. Axis we will represent that positive axis x, y, z. There we have a initial position may be represented as P1. Final position may be taken as P2. There vector can be taken as R1. This can be taken as R2. Now for that three-dimensional manner, R1 vector equal to x1 into I cap plus y1 into j cap, unit vectors, direction representation, I cap, j cap and z1 into k cap. And for that R2 vector, x2 into I cap, y2 into j cap plus z2 into k cap. There displacement is nothing but the shortest distance between initial to that final position. That can be represented as del r vector. Further, already we notated del r vector equal to r2 vector, that is del r vector equal to r2 vector minus r1 vector. That can be similarly, it takes place x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. So it contains both magnitude and direction. Suppose we need here also magnitude only, means del r modulus del r vector is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square if you take magnitude alone. But direction is from that initial P1 position to that P2 position only. Similarly for that two-dimensional manner already we completed. There we have here some example problems to relate that distance traveled and displacement. That example problems we are going to take on our book in that page number, that exercise number is 2.7. There we have an example problem. That example problem is 2.15. What they are given means, assuming your school is located 2 kilometers away from your home. In the morning you are going to school and in the evening you come back home. In this entire trip, what is the distance traveled and displacement? So example problem 2.15. There we have a content. We are in home. Initially morning. Our school here. We want to move from our home to that school. Actual distance is 2 kilometers. Reach our school. We study. At that 4:30, we return back to our home. So from here to we move in the morning itself. Further after 4:30, we are traveling here. Morning traveled distance is 2 kilometers. Evening traveled kilometer is another further 2 kilometers. We want to spend our energy for moving from one place to another place physically. Anyhow, here we want to calculate both distance traveled and displacement. According to our definition, what is the distance traveled throughout the trip means morning itself we traveled 2 kilometers, evening further 2 kilometers. Total length of the path in our trip is 4 kilometers. So that's why in our trip distance traveled is 4 kilometers because 2 kilometers plus 2 kilometers. But initial and final positions are our home itself. If initial and final positions are same means shortest distance value is 0. Shortest distance value is 0. So that's why our displacement value equal to 0 kilometer. But the distance traveled is 4 kilometer. We have some other examples also. It is a ground surface. We are standing. We throw a stone upwards. If any particle if we throw upwards, it moves up and up, but it makes a deceleration. Time to time, velocity decreases and reach one final maximum height. If you throw a stone, that particle is decelerated because opposite to the direction of the gravity we are throwing, and if the particle reaches this position, further it is returned back. We have a height h equal to 0.5 kilometer. Then if we throw the stone from our hand vertically upwards, it travelled 0.5 kilometer and reaches the maximum point. Further it comes in our hand. So travelling upward 0.5 kilometer, downward further 0.5 kilometer. That particle stone travelled distance travelled is totally 1 kilometer. What about that initial and the final position? Our hand is itself here, initial as well as the final position. So that's why displacement 0 kilometer for vertically throwing object. For moving from our home to school and school to finally home itself means that we have a distance travelled value, but displacement value is 0. Similar problem we are taking vertically thrown up object. Another 3-dimensional manner in a circular path or 2-dimensional manner we can take it. Here 2-dimensional manner only. We are travelling from this A position to that B position through the circumference of that circle, which has the radius r. If we move from A position to the B position, we can take both distance travelled and displacement. What is that distance travelled? Distance travelled is nothing but actual length of the path. Total circumference is 2 pi r. Half a circumference that can be taken as 2 pi r divided by 2, that is pi r. Suppose radius is equal to 1 meter. Then we can take the pi contains a numerical value 3.14 into 1 meter. There we have here 3.14 meter is a distance travelled. But shortest distance between initial and the final positions are 1 meter and 1 meter because that displacement equal to 2r itself. R value is 1 meter. That's why 2 meter alone. If any particle moves in a circular path, it completes a semicircular path alone. At the time, distance traveled is a pi r, displacement is a 2r. Already, this type of question is asked in our NEET ideas. Displacement as well as that distance traveled. So here is a minimum value for that displacement, but some other value may be take place. That is a 3.14 meter. Suppose if we complete one circular path, there we have a distance traveled is 2 pi r. If we move from A position to that further, finally A position itself means displacement maybe takes place here 0 itself. Whatever be the number of times you have travelled through that circumference of that circular path, if initial and final positions are same, displacement value is 0. Distance travelled means if you complete 3 times, there we can take on 3 into 2 pi r. If you complete 5 times, 5 into 2 pi r, the distance travelled value takes increases. How many times it takes complete that path like that. But initial and final position is same means displacement value is 0. If we move from A position to B position, there we have both distance travelled and displacement. Okay, we have relation between that distance and displacement, but distance is nothing but a actual length of the path, but displacement is shortest distance between initial and final position. Distance is a scalar quantity, displacement is a vector quantity. Vector quantity contains both paths, that is magnitude and direction. That's why it takes place only one respective value displacement, but distance is we have many paths, many values we have. Anyway, you have to go through our book distance and displacement in our 2.7 topic up to that before 2.8. There we have a note also. The note is not given proper manner, but anyway you have to go through, and we have a problem 2.17 you will see later. Okay, thank you for